Chapter 18, Aqueous Ionic Equilibrium, also known as Ice Tables Part 3. I like this, the definition, or not the definition, the quote here. In the strictly scientific sense of the word, insolubility does not exist. And even those substances characterized by the most obstinate resistance to the solvent action of water may be properly designated as extraordinarily difficult of solution, not as insoluble. Because insoluble would mean that not one molecule, not one formula unit dissolves in all the water that it's sitting in. And that's going to happen. For normal purposes, they may be considered insoluble. But, we're just blowing up all the things you learned in Chem 1A. Mm-hmm. We're going to talk about antifreeze. I'm not going to test you on the antifreeze stuff. So every year, thousands of cats and dogs die from ingesting antifreeze. Do you know why? Why would they eat it? It tastes sweet. And people are not always very responsible when they change their antifreeze, and they'll collect the old stuff in a pan, or sometimes people dump it in the gutter and let it go down to the river. Also a very, very bad idea. It has a sweet taste, and so if it's left out, dogs and cats may come and drink some of it. It's an alcohol, and so the first symptom that it causes looks like drunkenness. Why is my dog being such a dork? The real problem is that it gets metabolized to glycolic acid, which gets into the bloodstream, alters the pH of the blood. And that can be really, really bad. So blood pH is very important because many proteins in your body, or in a dog's body, only function within a very narrow range of pH. For humans, it's 7.36 to 7.42. Outside of that, you're at death's door or dead. So, not good. How does your body maintain the pH in such a tight range? By using buffers. What is a buffer, you may ask? It's a chemical system that resists change in pH, and it does so by neutralizing acid that's added and neutralizing base. So whatever you throw at it, it can neutralize. So an important blood buffer is a mixture of carbonic acid and bicarbonate ion. So here's carbonic acid. That's a weak acid. It can react with hydroxide ion to form water and hydrogen carbonate ion. Hydrogen carbonate ion, being the conjugate base, can react with hydrogen ion to form carbonic acid. And so because both of these are present in large quantities, no matter what you put in there, one of these can neutralize it. And so normally that works really well, but if you get enough glycolic acid in there, it can overwhelm the buffer. The buffer can only do so much. Low blood pH results in acidosis. And the big danger there is it affects the equilibrium between hemoglobin and oxygen. And we talked about this earlier in the semester. Hemoglobin and oxygen are in an equilibrium with hemoglobin bound to the oxygen. And so where the concentration of oxygen is high, the hemoglobin picks it up. That's in your lungs. And then it travels through your bloodstream and encounters places that have lower oxygen concentrations, and it releases the oxygen. But the pH, if the pH is too low, we've got excess hydrogen ions. That's going to cause this whole equilibrium to shift to the left, and the hemoglobin is not going to carry oxygen as well. So then your body's like, we're not getting enough oxygen. We need to breathe more, right? So that can lead to hyperventilation, coma, and death. An interesting treatment is the administration of ethanol. So if an animal or a person has consumed ethylene glycol, the best thing you can do is give them a few stiff shots of alcohol, because the body prefers to metabolize ethanol. And so the ethanol is going to keep your body busy while the ethylene glycol has a chance to get out of your system. Anybody have any questions?